NASA's New Horizons spacecraft, one of the most ambitious and far-reaching missions ever launched by humanity, completed its historic journey through the Pluto system in July 2015, marking the first and only time a spacecraft has made a close flyby of that distant and mysterious dwarf planet. Before New Horizons arrived, Pluto was little more than a blurry dot in telescopic images, an enigmatic world on the outer frontier of our solar system that scientists longed to explore in detail. When the spacecraft finally swept past Pluto after a journey of nearly a decade, it delivered a treasure trove of images and scientific data that transformed our understanding of this remote world. What had once been thought of as a cold, inert, frozen sphere was revealed to be surprisingly dynamic, with vast plains of nitrogen ice, towering mountains of water ice, an unexpectedly complex atmosphere, and geological features that hinted at ongoing processes beneath its surface. This encounter was more than just a milestone. It reshaped the way humanity perceives the outer solar system. Sailing onward after completing its groundbreaking Pluto mission, New Horizons continued deeper into the Kuiper Belt, a vast, donut-shaped region beyond Neptune filled with icy remnants from the early formation of the solar system. These objects, known as Kuiper Belt objects or KBOs, are thought to be some of the most primitive bodies in existence, ancient time capsules holding clues to how our solar system formed more than 4.5 billion years ago. On January 1, 2019, New Horizons successfully executed a close flyby of one such object, Arakoth, a small, elongated, contact binary world located billions of miles from Earth. This flyby was the most distant ever conducted by a spacecraft. Arakoth revealed itself as a remarkable object shaped somewhat like a snowman, with two lobes gently fused together, a shape that provided compelling evidence for theories about how small bodies in the early solar system slowly accumulated material through gentle collisions rather than violent impacts. This discovery was crucial, helping scientists refine their models of planetary formation and offering a rare glimpse into the primordial materials that predate Earth itself. The Kuiper Belt, often described as a frozen relic field, contains countless more icy bodies, ranging from tiny fragments to dwarf planets, each holding unique scientific value. Although astronomers have cataloged many KBOs, it is widely believed that the majority of these distant objects remain undiscovered, simply because they are too faint and too far away for current telescopes to detect easily. These objects have remained in near-perfect preservation since the early days of the solar system, making them invaluable targets for exploration. New Horizons, traveling through this untouched and ancient region, provides humanity with a unique opportunity to capture first-hand data from a zone that no other spacecraft has explored in such detail. Every observation it sends back, whether of dust, particles, plasma, or distant celestial objects, adds another piece to the puzzle of our solar system's origins. For New Horizons itself, the potential for further discovery is still very much alive. Even though the spacecraft is traveling through a remote and increasingly faint region of space, its instruments continue to function, allowing it to act as a roaming observatory in the outer heliosphere. The idea that more groundbreaking science lies on the horizon is more than just a clever phrase. It is a literal description of the mission's ongoing potential. Researchers continue to analyze its data, search for additional targets, and evaluate the spacecraft's capabilities as it ventures farther from the sun's influence. The farther New Horizons travels, the more valuable its measurements become because very few spacecraft have reached such distances. Only the Voyager probes, launched in the 1970s, have moved deeper into interstellar space, and their decades-old instruments are slowly fading. New Horizons, with more modern sensors, still has much to contribute. Late last year, the U.S. National Academies published an extensive study titled The Next Decade of Discovery in Solar and Space Physics, Exploring and Safeguarding Humanity's Home in Space. This report, commonly referred to as the Heliophysics Decadal Survey, outlines priorities for the next 10 years of solar and space science research. One of its major observations emphasized that one of the key challenges moving forward is ensuring that the scientific community continues receiving crucial data from missions like New Horizons and the Voyager spacecraft. These probes, which are among the only long-lived explorers operating in the distant outer heliosphere and beyond, capture environmental conditions that cannot be observed from anywhere else. They are humanity's only direct instruments, studying the transition zone where the sun's influence begins to fade and the interstellar environment starts to dominate. Without these spacecraft, scientists would lose access to essential data about the nature of the heliospheric boundary, a region that marks the true edge of our solar neighborhood. The report also pointed out that as New Horizons travels farther outward, it approaches one of the most intriguing frontiers in space science, the boundary of the solar system itself. This region, where the pressure of solar wind weakens and gives way to cosmic interstellar particles, is a complex and turbulent zone filled with scientific mysteries. Understanding this transition is critical not only for planetary science, but also for understanding how cosmic radiation interacts with our solar system, how solar storms propagate, and how the sun's protective bubble, known as the heliosphere, shields Earth and other planets from harmful high-energy particles. As New Horizons heads deeper into this boundary region, its measurements of dust, plasma waves, magnetic fields, and energetic particles will help researchers map this frontier with better precision. Every bit of data draws humanity a little closer to charting the true dimensions of our solar system and its place within the galaxy. According to Alan Stern, the principal investigator of New Horizons from the Southwest Research Institute in Boulder, Colorado, the findings in the Heliospheric Decadal Report carry enormous significance. Stern emphasized that this recognition from the broader scientific community serves as an independent validation of both the mission's accomplishments and its continuing scientific value. He noted that New Horizons provides insights that simply cannot be obtained through other means, making it an irreplaceable asset for heliophysics and planetary science alike. For him and the rest of the mission team, this acknowledgement reinforces the importance of maintaining support for the spacecraft as it travels deeper into uncharted territory. He explained that the unique observations New Horizons gathers, especially as it moves into a region seldom touched by sunlight and barely influenced by the sun's magnetic field, offer a transformative opportunity to expand human knowledge about the outer solar system and the beginning of interstellar space. In essence, New Horizons serves as a bridge between planetary exploration and the study of the broader galactic environment. It has already revolutionized our understanding of Pluto and Arrokoth, and now it continues to capture data that will shape future models of heliospheric physics and interstellar conditions. As mission planners assess the spacecraft's remaining fuel, power supply, and potential targets, they remain hopeful that New Horizons will continue functioning for many more years, sending back information that only a spacecraft in its unique position can provide. Just as Voyager 1 and 2 continue their journeys decades after launch, New Horizons may one day become humanity's next silent ambassador to the stars, a small, distant probe carrying our curiosity into the vast darkness beyond the solar system.